I've been thinking lately about the laziest machine learning algorithm out there. Although this question may seem a little bit unproductive at first, it actually offers key insights into the efficiency and resource utilization of different machine learning algorithms. In this video, I will walk you through my thought process in defining the concept of laziness in terms of machine learning algorithms. And let's see which one will win this title. Alright, so who are our machine learning algorithm candidates? I wanted to select well-known machine learning algorithms, the types supported by scikit-learn library. And to ensure fairness, all the algorithms should be supervised learning algorithms. Therefore, I decided to compare the simplest machine learning algorithms. The first one is the linear regression. In this example, predicting the cost of different types of food, assuming a simple linear relationship between cost and review. The higher the review, the higher the cost. And candidate number 2 is KNN, K nearest neighbors, predicting the cost of different types of food based on the average cost of the K nearest data point of similar reviews. While the third candidate is decision tree, while predicting the cost of different types of food based on a series of questions about the reviews. Like, for example, if less than 2 stars, then low cost, and so on. These models cover linear and nonlinear models, instance-based and model-based models, tree-based and non-tree-based models. When I started wondering what makes an algorithm lazy, I approached it in the same way I categorize a person as lazy. A lazy person would keep postponing chores or tasks to the next day and always do the minimum amount of work possible. To apply this definition of laziness to the machine learning algorithms, I'll focus on the following criteria. 1. The number of parameters it needs to estimate during the learning process or the training process. 2. A comparison between the computation efficiency needed during the training phase and the computational efficiency needed during the testing phase. The laziest algorithm would put minimal effort during the training stage, postponing all the work to the testing stage, and estimating the fewest parameters possible. Starting with the first criterion, the number of parameters. Linear regression aims to model the relationship between one or more independent variables and a dependent variable by fitting linear equation to observed data. It typically ranges between 2 parameters in the case of a single feature, or even more, reflecting the number of coefficients. Consequently, the number of coefficients remains relatively low to moderate. KNN, on another hand, as its approach in the prediction of a data point is determined by the majority votes of its K nearest neighbors, it doesn't involve the explicit estimation of parameters in the same manner as some other models. However, it does rely on a critical parameter K, which denotes the number of nearest neighbors to consider. K plays a vital role in KNN and influencing bias variance trade-off, but it doesn't explicitly compute K during training, so I'll put it as 0 or low. Regarding decision trees, the determination of the number of nodes and split results in a higher count, relatively speaking at least. Decision trees entail the creation of numerous nodes and splits during the training process, make it relatively more complex in terms of number of components involved. The second criterion is the most crucial one to me, which is the comparison between computational intensity during training versus testing. Training phase in linear regression involves finding optimal coefficients that minimize the error between predicted and actual values, usually achieved through solving a system of linear equations. This process is computationally efficient, especially if matrix implementation is adopted. During testing phase, the model applies the learned coefficient to a new data point through simple matrix operations, maintaining low computational requirements. On the other hand, the training phase in KNN involves sorting the entire dataset without explicitly building a model, leading to a low computational requirements. It's worth mentioning that it's potentially high memory usage, especially for large datasets, but I don't include memory in my criteria. On another hand, however, for the testing phase, KNN calculates the distance between the new data point, and the stored training instances can be a little bit computationally expensive, leading to high computation demands, particularly with datasets with large sample sizes and high dimensional spaces. Finally, for the decision tree, the training involves recursively partitioning datasets based on different features and thresholds, requiring moderate computation, especially for complex dataset. And for the testing phase, evaluating a new data point using decision tree involves moderate computational effort, especially for trees with limited depth and simple decision rules. So, after analyzing the criteria and considering the explanation provided for each of the algorithms, we can easily rule out decision trees. But to be honest, choosing between linear regression and KNN wasn't that easy. On one hand, linear regression has minimal computational requirements during both training and testing phase. On another hand, KNN doesn't learn anything in the training stage, and it stands up to its commitment in the testing stage and does hard work. But I tend to lean toward naming KNN as the laziest machine learning algorithm, as having linear regression done low in terms of the second criteria might be seen as effectiveness rather than laziness. So, in my opinion, KNN is the laziest algorithm. What do you think? Did I miss anything? Let me know your opinion in the comments. And if you like this content, please like, share, and subscribe.